All right, more limit practice. All right, so my first strategy to evaluating a limit is to try direct substitution. If direct substitution results in a 0 over 0, that means that your limit has an indeterminate form, either a whole or a vertical asymptote. For now, there will only be a 0 over 0, but we'll get into the other cases. So, but I just want to make sure that we understand you can always factor. Observe the situation after you factor. If you can factor, go for it. So I'm going to look at this problem, the limit as x approaches -8. Well, on the one hand, I could plug in x equals -8, and I would get -8 quantity squared times 2 plus 10 times -8 minus 48 over 8 times -8 plus 64. Let's find out. Well, can I factor anything on the top? Yeah, I can factor out a 2, getting me 2 times x squared plus 5x minus 24. You notice this is similar to when we reviewed the Algebra 2 problems at the beginning of the week. Haha, you see what I did there? That's called very smart move. I tried to come up with something clever and backfired on me. But the point is, it's a throwback to Monday, Tuesday rather. So let's factor out the bottom. We've got x, 8x plus 64, so that's 8 times x. 8 times 8 is 64, so we can factor the bottom as 8 times x plus 8. But remember, we can factor the top. What two numbers multiply to -24 and add to 5? That'd be +5 and -3. So we've got the limit as x approaches -8. So that would be 2 times x plus 8, x minus 3. All that over 8 times x plus 8. And there's nothing to factor on the bottom. So if I plug in x equals -8, do I have a problem? Yes. If I plug in x equals -8, that'd be -8 plus 8 over -8 plus 8. I've got a 0 over 0. Therefore, there's a hole in the graph at this particular value of x. When x is -8, I get a hole in the graph, and Isaac Newton goes nuts. So now I'm going to look at this problem. The limit as x approaches -8, 2 times x minus 3 over 8, and there's nothing else there. So it's just 2 times x minus 3 over 8. Now, is it legal for me to plug in x equals -8? The answer, yes, it's totally legal now. So let's plug this in. We've got 2 times -8 minus 3 over 8. That's 2 times -11 over 8, which is -22 over 8. Your professor's probably going to want you to simplify that fraction. A negative divided by a negative is a negative, and 22/8 can both be divided by 2, so that'd be 11/4. Or, if you're a decimal person, -2.75. Everybody happy. But the point is, as x gets closer and closer and closer to -8, y gets closer and closer and closer to -11/4. But that point, -8, -11/4, does not actually exist. Moving on to problem number 2, the limit as x approaches 7. Well, when in doubt, plug it in, or, you know what? Factor, and let's see if we have a problem. The limit as x approaches 7. Can I factor the top? Yeah, another throwback problem from the Algebra 2 review. We get x squared minus x minus 42. What two numbers multiply to -42 and added -1? That would be -7 and +6. If I plug in x equals 7, that's going to get me a 0 on top. Let's find out if we get a 0 on the bottom. All right, let me factor out the GCF, which is 2, getting me x squared minus 10x plus 21. I'm still not done factoring because I can factor that quadratic trinomial. What two numbers multiply to 21 and add to negative 10? That's going to be negative 3 and negative 7. So this is the limit as x approaches 7 for x minus 7 times x plus 6 over 2 x minus 7 x minus 3. Do I have a problem when x equals 7? Oh yeah, there's your problem there, son. That x minus 7 over x minus 7, that becomes 7 minus 7 over 7 minus 7, 0 over 0, that'd be $400. So that'd be the limit as x approaches 7, knowing that x equals 7 is going to give me a hole. But in calculus, we try to figure out, well, where is that hole? So the limit as x approaches 7 of x plus 6 over 2 times the quantity of x minus 3. Now, is it totally legal for me to plug in the limit as x approaches 7? Yeah, it's totally legal for me to plug in x equals 7 now. So now I'm going to go to 7 plus 6 over 2 times 7 minus 3. 7 plus 6 is 13. 2 times 7 minus 3. 7 minus 3 is 4. So 13 over 8. Is that simplified? Yes. So the point of this is, as x gets closer and closer and closer to 7, y gets closer and closer and closer to 13/8, or 1 5/8 if you prefer a mixed number. Okay, see if you can do the next few problems independently. Problem number 4, I'll put it right here. Sorry about the delay. Just wanted to make sure I got the problem correctly. All right, number 3 and number 4. See if you can do these problems independently. Okay, let's take a look at number 3. Okay, so whenever I plug in a limit, the limit as x approaches 8, I could plug in 8 squared plus 2x, 8 squared plus 2 times 8 minus 80, all that over 2 times 8 cubed. The point is to test out whether it's 0 over 0. It could take a while, so there's no harm in factoring and observing the situation. Well, let's do that. What two numbers multiply to negative 80 and add to 2? Well, that would be x plus 10, x minus 8. Ooh, I can already sense that that x minus 8 is going to cause me trouble in this problem. All right, let's take a look at the bottom. Well, I can factor out a 2x And then I get x squared minus 12x plus 32. Okay, so that tells me that this bottom right x squared minus 12x plus 32 can be factored a little bit more. So let's do that. The limit as x approaches 8. So on the top I get x plus 10, x minus 8. Going to be a huge problem for x equals 8. Okay, and on the bottom, what two numbers multiply to 32 and add to negative 12? Well, it has to be a negative-negative combination, but specifically, it has to be negative 4 and negative 8. So the bottom completely factors out to 2x times x minus 4 times x minus 8. Is there a problem with x equals 8? Oh yeah. Oh yeah. X equals 8 results in x minus 8 over x minus 8 becoming 0 over 0. That'll be $400. We acknowledge that x minus 8 over x minus 8 becomes a whole, but we want to figure out where that whole is. So we've got the limit as x approaches 8 of x plus 10 over 2 times x minus 4. Now I'm going to plug in x equals 8, and let's hope nothing goes wrong. So we get 8 plus 10 over 2 times 8 times 8 minus 4. Well, piece by piece, we're going to figure this out. The top part is simply 8 plus 10, so that is 18. All right, I'm going to do 8 minus 4 first. That's going to be 4. So then I get 2 times 8, which is, I'll just break that up. 2 times 8. 2 times 8 is 16. 16 times 4 is Nintendo 64. Can I break up 18 over 64? Let's see, can I divide something from the top and bottom? Just 2, I guess. 18 over 64 can be reduced to, that'd be 9 over 32, and I believe that's as simplified as it gets. So the limit as x approaches 8, as x approaches 8 for this particular function, y gets closer and closer and closer to 9 over 32. Okay, number 4. Is there a problem with x equals 10? Only time will tell. Let's find out. What two numbers multiply to 30 and add to negative 13? Well, that is a negative-negative combination of x minus 3, x minus 10. Okay, I'm going to take a look at the bottom. X squared minus 3x minus 70, two numbers that multiply to negative 70 and add to negative 3. That will be x minus 10, x plus 7. When I plug in x equals 10, do we have a problem here? Oh yeah, x minus 10 over x minus 10, that results in 0 over 0, that'll be $400. So now we've got the limit as x approaches 10 for x minus 3 over x plus 7. Plug it in. Now I'm going to plug in 10 minus 3 over 10 plus 7. 10 minus 3 is 7. 10 plus 7 is 17. We're going to check our work. That's about as simplified as it gets. I believe we have time for one more. Okay. Actually, we have time for 2 more, because I do want to make sure we get this other case. Okay. Okay. Just want to make sure that we're good on these two cases and when to tell the difference. Okay, so first things first. Number 5, the limit as x approaches 0 for x squared minus 4 over, oh sorry, that should be an x squared. Over x squared minus 7x plus 10. Okay, so x squared minus 4 over x squared minus 7x plus 10. Well, when in doubt, you could just use direct substitution, right? And you would get 0 squared minus 4 over 0 squared minus 7 times 0 over 10 plus 10. And you wouldn't get a whole. You wouldn't get a whole. Just to show you that even if you factored, just to get good practice with it, x plus 2, x minus 2, x minus 5, x minus 2, is there a whole at x equals 0? No, but there's a whole at x equals 2. I don't care. The problem does not ask me, is there a whole at x equals 2? So even though you could cancel this out, make this problem easier, go for it, but just acknowledge that the whole is not at x equals 0. So I'm just going to plug it in now. Even though you could just cancel out the x minus 2 part. So I'm left with 0 plus 2, which is 2, times negative 2, negative 5, negative 2. Again, you could have just canceled this out all along. And in the end, you would get negative 2/5. But just know that the point itself actually exists here. The limit as x approaches 0. As x gets closer and closer and closer to 0, y gets closer and closer and closer to negative 2/5. Now let's take a look at number 6 and then we'll call it a day. All right, the limit as x approaches 0. Let's look at the top, let's look at the bottom. Clearly, if I plug in x equals 0, 0 over 0, we've got a whole. I'm not happy. So the limit as x approaches 0, what can we do to counteract this problem? We are going to factor. So we've got x squared minus 2x plus 1. And on the bottom, I'm going to factor out, again, another x. So I've got 2x squared plus x minus 2. There's your problem. That x over x creates 0 over 0. The whole is at x equals 0. X equals 0 creates y equals 0 over 0. But now, you know what? Limit as x approaches 0. Let's think critically about this. We get x squared minus 2x plus 1, 2x squared plus x minus 2. Let's think about this. Am I going to get 0 over 0 here? No. So I'm just literally going to plug in x equals 0. I get 0 squared minus 2 times 0 plus 1, 2 times 0 squared plus 0 minus 2. 0, 0, 0, 0, except for that 1 over negative 2. So that's negative 1/2. But the point itself is a whole in this situation. X equals 0, y equals negative 1/2 is a whole in the graph. I hope you guys enjoy your weekend. Next week we will introduce L'Hopital's rule.